Lesson 8-7, we are looking into solving inequalities. This time, our last lesson, we talked about inequalities and what they were. The essential question today is, when does the inequality sign reverse? And when does it not reverse? Now, this could be very tricky for some students if they're not paying attention to the notes. So make sure you understand what's going on. First of all, we'll just start here. It's a rule. What's the rule? When multiplying or dividing by a negative, you must reverse the inequality symbol. Now that definition is straight from your textbook. It's not very good. So let's expand on it. It's taught as a rule, but really it is a property of multiplication and division. This is the only thing you need to watch for that is different from solving equations. So what is this inequality rule we're talking about, and why does it happen? Let's investigate with an investigation. It says, using the properties of equality, perform each operation as noted to both sides of the inequality. Then mark it true or false. In the first one, it says add 3 to both sides. So you add 3 to both sides like this. 16 plus 3 is 19, and 8 plus 3 is 11. We bring down the sign just as it is, and it's still a true statement. 19 is still larger than 11. So we'll mark this one as true. And then we keep on going through with the next one, adding -2 to both sides. And 16 plus -2 is now 14, and 8 plus -2 is now 6. We bring down the sign. 14 is larger than 6. It is still true. Now we go to number 3. We subtract 6 from both sides. And 16 minus 6 is 10, and 8 minus 6 is 2. And we bring down the sign, and we can see that 10 is still larger than 2. Then we subtract -4 from both sides. Now, this one looks weird. We subtract -4. If you remember back to our first unit this year, we learned that subtracting a negative is the same thing as adding a positive. And so we know that when we start with 16 and we take away negatives, we're not going down. We're going actually up. So we want to take the negatives away. So that's going to bring us to 20. And if you're not sure about that, you could use the additive inverse on those subtraction signs. 8 minus -4 is 12. Bring down the sign, and it is still true. 20 is larger than 12. Number 5, we're supposed to multiply both sides by 3. And 16 times 3 is 48. And 8 times 3 is 24. We bring down the sign, and it's still true. 48 is larger than 24. Number 6, we multiply both sides by a -5. And 16 times -5, a positive times a negative is a negative, and that is -80. And on the right side, 8 times -5 is -40, and we bring down the sign. Is -80 larger than -40? No, it's false. Well, it was true up here. 16 is larger than 8, but now we multiplied both sides by a negative during the property of equality, and we found out that our sign was now wrong. Let's try number 7. We're going to divide both sides by 4, and 16 divided by 4 is 4, and 8 divided by 4 is 2. And we bring down the sign and we find out that it is still true. 4 is larger than 2. And now we'll divide both sides by -2. And 16 divided by -2 is -8. And 8 divided by -2 is -4. And we bring down the sign and look at that. We found another false statement. -8 is smaller than -4, not larger. So this is another false statement. And in this one, we realized during the property of equality, we're dividing both sides by a negative. Now let's take a look at the next investigation. This is a scale balance where A is greater than B. Plug in numbers of your choice to make it true. Now I'm going to offer to you that we're just going to use 3 and 2 because we want to keep our numbers simple. 3 is definitely larger than 2. And you see how that scale is weighing more on the A side? We just got done learning about hangers, and this hanger is not equal. Now, try each of the below and label them true or false. We have A's and we have B's. Sorry about that. And so we're going to use the substitution property. Let's write that up here. And we're going to basically make all of these A's into parentheses, because we're going to sub in 3 for all of the A's. So just smash a 3 right on top of the A. And let's get these operations done. So the first operation is 3 plus 2 is 5. Then 3 minus 2 is 1. 3 plus a negative 2 is 1. 3 minus a negative 2 is actually 5, and you can use the additive inverse to prove it. 3 times 2 is 6. 3 divided by 2 is 1.5. 3 times negative 2 is negative 6. And 3 divided by negative 2 is negative 1.5. Now we'll move over to the B side. We'll use subprop and we'll make all these into parentheses. And then we're going to want to substitute 2 in for all of the B's. So write a nice 2 right over the B. And then we'll do the operations. 2 plus 2 is 4. 2 minus 2 is 0. 2 plus a negative 2 is 0. 2 minus negative 2 is 4. 2 times 2 is 4. 2 divided by 2 is 1. 2 divided by negative 2, 2 times negative 2 is negative 4. And 2 divided by negative 2 is negative 1. Now we're going to compare. Let's compare the first row. We have a 5 over on the left, and we have a 4 on the right. Is the scale still correct? Yes, it's true. The next one, a 1 on the left, a 0 on the right. It's still true. 1 is still greater than 0. 5 is still greater than 4. 6 is still greater than 4. 1.5 is still greater than 1. Negative 6 is not greater than negative 4. So that would be true. That would be false now. And negative 1.5 is smaller than negative 1. It would weigh less. That's now a false scale. So here we found 2 false ones. And if you look, we're multiplying by a negative on both sides, and we're also dividing by a negative on both sides to create those false statements. So what does this all mean? Well, when we go down to the next one, we can look here at using a number line. Examine the coordinates while performing the property of quality. That is actually a mistake. It should say equality, the property of equality. Okay, let's take a look at what's going on. In this statement right here, we have 1 is less than 2, and it is. We don't have a problem with that. We can see it right here in this top number line. 1 is less than 2 on a number line. The heart is worth 2, and the smiley face is worth 1. But when you multiply both sides by a negative, just like that the equality rule says up above, something changes. It commands each of the original numbers to become their opposites. So 1 times negative 1 is now negative 1, and 2 times negative 1 is now negative 2. Well, when that happens, the heart and the happy face are actually changing positions. And now you can see that the happy face is now larger than the heart. So that it's a switch, it's reversing. So because of that, we have to take this sign and turn it around. Now that only happens when you're multiplying and dividing by negatives during the property of equality. So what's happened to the happy face and the heart? They actually reversed. And so therefore, we need to reverse our sign. Now that we know it's proven, we're going to practice it just a bit. Okay, hold up. I did not reverse the sign over here. So this is actually incorrect right here. It should be facing this way now. I reversed it right from here to here, and I should have wrote this one that I already reversed right here. So please catch that and correct that in your notes. All right, now let's start the examples. So in y, it says y plus 5 is greater than 11. So y has to be something to make the left side greater than 11. And to find that out, you want to deal with the constant first. Dealing with the constant, we're going to add a negative 5 to both sides. Now, that's not the rule that we learned today. We're not multiplying both sides by a negative, and we're not dividing both sides by a negative. Therefore, the sign stays the same. This is y is greater than 6. And now we're going to find out if it's actually true. So we're going to go down here, and we're going to circle a spot on the line graph, call it 6, and then we have to discuss, is it an open circle or closed circle? This one is an open circle, and that was in the previous lesson. So y is greater, and greater is to the right. Now all you have to do to check that your answer is right is pick something greater than 6. I'm going to pick 10. So this is 7, 8, 9, 10. 10 is definitely greater than 6, and if I put 10 right here, substitute it in, 10 plus 5 is 15, and that is greater than 11. So I know my inequality is correct. Moving on to the next one. We're going to remove the 7 by adding a negative 7 to both sides, and that's adding negatives, so therefore we do not switch the sign. That is, x is less than or equal to 3. I go down here and I call a spot on my number line 3. Oops, not negative. Positive, like my answer says. Circle it, and this is a closed circle because it's or equal to, just like the previous lesson. So x is less than, so it's going to go to the left. Now, I need to pick something that is less than 3. A super easy number to pick would be 0. That is less. So if I put 0 right here where the x is, 0 plus 7 is 7, and 7 is indeed less than 10. So we know we got it right. How about the next one? We have a subtraction sign. I like to use the additive inverse. And now we're going to add a positive 1.5 to remove that to both sides. And this is h is less than 6.5. So we're going to go down and circle a spot on the line graph, call it 6.5. And this one is an open circle, and h is less than, so it's going to go to the left. Now pick anything that's less than 6.5. A favorite one is 0. So I'll put a 0 up here, and 0 plus negative 1.5 is negative 1.5. And that is less than 5. So I know it is correct. Well, so far, on the top 3, we didn't reverse any of the signs. And you know why? Because we're adding to both sides. We're not multiplying or dividing by negatives yet. So let's try another one. Now our variable's on the right side, and we're adding 7 to it. To undo that, we're going to add a negative 7 to both sides. 3 plus negative 7 is negative 4. I still did not reverse the sign. But this one, I'm going to write down warning. Why is it a warning? Well, we're going to be graphing, and we have to read it backwards. So write down, read the answer backwards. Sorry about the sloppy writing on that. All right, so how do we read backwards? Well, we start back here at the G, and you read in this way. G is less than or equal to negative 4. See how I read everything backwards, including the sign? So I mark some spot on the number line, and I call it negative 4. And G is less than, so it's going to go to the left. Now, on this one, I also have to color it in. Now, to make sure that I'm correct, let's pick something that's less than negative 4. Let's pick something easy, like negative 10. If we put negative 10 in here, in this spot, negative 10 plus 7 is negative 3, and negative 3 is less than 3, so we know we got it right. Moving on to the next one, x is right here, and x now has a coefficient. We've been working on constants so far. Now we're to the coefficients. So to undo the coefficient, to get rid of it, to make it a 1, we're going to divide it by itself to make a positive 1. If we do it to one side, we do it to the other. This is what the lesson's been all about. At this moment, we're dividing both sides, and not only are we dividing both sides with the property of equality, we are dividing by a negative. And that's when the sign reverses. So x is, and this sign now reverses, is 3. X is greater than 3. Now let's find out if we're right. Call it at 3 down here, give it a circle. And this is an open circle, and our answer says x is greater than 3. So we're going to go to the right. All right, it's time to test to see if we got the right answer. What's a number that's greater than 3? I think 10's greater. That definitely works. So we put 10 right here. What is negative 9 times 10? Negative 90. Is negative 90 actually smaller than negative 27? Yes, it is. And so it's correct. Likewise, if you're on the left side and you chose something like 0, put 0 in here. 0 times negative 9 is 0. Is 0 less than negative 27? No. So all of this area would be a no-go. So we have the answer correct. The next example says x over 5 with a little negative sign here. But before we deal with this, we need to deal with our constant first. And to get rid of that constant and change it into a 0, we're going to add a negative 4 to both sides. And that's negative x fifths is greater than or equal to 7. Now the sign did not reverse because we're adding negatives to both sides. And we never had an issue with that during the investigation. So we're going to move on to the coefficient. And that's right here. What's in front of the x that we just cannot see? 1. A 1. And so to get rid of this negative 1 over 5, we multiply it by negative 5 over 1 to both sides. And this is that moment when we're multiplying both sides during the property of equality by a negative that the sign reverses. This will be negative 35 on this side, and this will be x over here. Let's test it on our number line. We're going to need a circle, and it's got to be closed. We'll call it negative 35, and the x is less than, so we're going to go to the left. Now let's pick a number that's less than negative 35. Well, let's pick something that is easily handled by dividing by 5. So let's go negative 40. That's easily handled. So if this is a negative 40 up here, negative 40 divided by 5 is a negative 8. And negative 8 times this negative is a positive 8. And that 8 plus this 4 is 12, and 12 is greater or equal to 11. So it works. We know we got it right. Let's try a couple of word problems before you get to try some on your own. Beck is going bowling and has $25 to spend. So Beck only has $25 to spend. And this is what he's spending it on. What's he spending it on? Write and solve an inequality to find the maximum number of games he can bowl if each game costs $3.75. So each game is $3.75, and that's per game. So we're going to use G as our variable for how many games he gets to bowl. But Beck also buys a snack for $2. So we have to add that in to the amount that he's spending. Now we need an inequality sign. Over in the box is what he's spending, but over here is how much he has to spend. Can he spend $24? Yep, he's got enough. Can he spend $25?
Yep.
Yes, he has enough. Can he spend $25.01?
No.
He does not. So this box over here has to be less than 25 or equal to. So now that we have an inequality set, we're going to use properties of equality to solve. Our variables right here, we have to deal with a coefficient and a constant. Let's deal with the constant first by adding a -2 to both sides. And 25 plus -2 is 23. Now let's deal with the coefficient by dividing by 3 75/100. Now this is definitely a spot where you use a calculator and you type it in, and it comes out to G is less than or equal to 6 and 1 with a repeating 3. Now what would that mean for games? Well, the answer would be G is less than or equal to 6 games, because you really can't buy this amount of games. So G is less than 6 games. So you can bowl 6 games or less. Let's take a look at Ben. Ben prepared 28 bags of granola to sell at a school fundraiser. She also received a $10 donation. Write and solve an inequality to find the price she should charge for each bag of granola if she wants to raise at least $115. So we're going to write down $115. And then over here is what she has to raise. Well, what is she raising? Well, she's raising money and she wants it to be at least $115. So she has 28 bags and she doesn't know the price to charge. So we're going to use P for the variable. Plus, she got a straightforward $10 donation. So she's already on her way. Now, what does she want that box to be? She wants it to be at least $115. So is she satisfied with $116? Yes. $117? Yes. $115? Yes. $114? No. So she needs this box to be larger or equal to $115 to meet her goal. So we're going to deal with the variable, and the variable has a coefficient and a constant. We're dealing with the constant first by adding a -10 to both sides. And 28p is larger than or equal to 105. Now we didn't reverse the sign because we're adding negatives to both sides. We're not multiplying and dividing by negatives on both sides. So let's go ahead and take care of the 28 by dividing by 28. And p is greater than or equal to, and I would put that in your calculators, and you'll get $3.75. So she needs to sell each bag for at least $3.75 or more. That's the price per bag. It's your turn. Pause the video and try the top 3 with graphing. Make sure to check them to make sure you're getting them right. Pause now. All right, here are the answers for the 3. I do want you to pay attention to the third one down here. That is the moment where you're multiplying both sides by a negative and the sign reverses. So hopefully you caught that one. That is the only of those 3 that do that. Now pause the video again and try the next 3. Pause now. All right, take a look at these 3, and you can see that 2 of them are the reverse type of problems, and the center one was not. So hopefully you've picked up on which ones you're reversing now and which ones you aren't. Let's finish off by doing this word problem together. Brock works for a lawn service company. It takes Brock's 3/4 of an hour to mow one lawn. If he works more than 8 hours, he gets a half-hour lunch break. Write and solve inequality to find the number of lawns he can mow if he works at least 14 hours. So on this one, he's working 14 hours. And that means he gets the half-hour lunch break. Now, each lawn takes 3/4 of an hour. And so we're going to put a fancy L right here because I don't want to put a lowercase l because it might look like the number 1. And then we're going to take away the half hour because he gets that for lunch and he's not mowing any lawns during lunch. So this side has to be how many lawns can he mow in 14 hours? So what kind of inequality sign are we going to use? Well, if you look here in the sentence, it says write and solve an inequality to find the number of lawns he can mow if he works at least 14 hours. So we want this to be at least. Which way does the inequality sign go? It goes this way, or at least. Now let's go ahead and start. We're going to use additive inverse here and add a positive half to both sides. That's going to give us 3/4 L is greater than or equal to 14.5. Then we'll multiply by its reciprocal on both sides. And that's tough to do on the right side here because we have a mixed number. So 2 times 14 is 28, and plus the 1 is 29 halves. Anyway. All right, and then this is 3. We can cross-reduce these two, and 29 times 2 is going to give us 58 over 1 times 3 is 3. There's no reversal of signs over here, and it says that the lawns have to be greater than 58/3. Well, what is 58/3? 58/3 in your calculator is 17 1/3 lawns. So that's how many lawns he has to at least do or greater. Now he can't do 1/3 of a lawn, so he's going to have to do 18 or more. Now come down here and put in your first name, last name, date, and period. And I'd like you just to search through this paper and look for any problems that are going to have reversals. There are a few, and make sure you find them before you begin. Number 1 is just simply adding a -9 to both sides. And that's m is less than 5. Number 6, oh no, not 6. Number 5, for example, is adding a -8 to both sides. And r is greater than -23. Still not a reversal. Let's find one reversal that is odd. Looking around. I don't see any. I see some evens that are reversals. So let's do an even that's reversal. 18. We'll divide by -5 on both sides. And since we're dividing by a negative on both sides, we're going to reverse that sign, and that's going to be -18. 25. And that's a reversal moment. At the bottom ones, you're going to do the same, solve them, and then you're going to graph them just like we did in the notes. Complete all the odds and the evens.